All right, welcome back, everyone. Today, we're diving into the one thing that can literally make or break your AI application out in the wild: speed. I mean, you can build the most amazing tool ever, but if it's slow, nobody's going to use it. So let's get into how you can make your AI apps absolutely lightning fast. And look, this right here gets to the absolute heart of it. Latency isn't just some techie metric on a dashboard. It's a user experience disaster waiting to happen. In a demo, sure, people are patient. But in production, a slow app is a failed app. The stakes are just incredibly high.
Okay, let's dive into this. First, we're going to talk about why latency is such an app killer. Then we'll become detectives and find our bottlenecks. After that, I've got 3 instant speed boosts for you. We'll cover the golden rule of measuring first. And finally, we'll get into some more advanced optimization techniques.
Right, section 1. Look, we all know a slow demo is kind of forgivable, but a slow production app is just not. Speed isn't some nice-to-have feature anymore. For AI apps, it is a core feature that directly impacts whether people stick around or just leave.
Okay, so this is the number you need to burn into your brain. Under 3 seconds. Anything more than that, and all the research shows you start losing people fast. Every single second of delay is just chipping away at your users' patience and the chance they'll ever come back.
So how do we fix it? Well, first we got to play detective. Before you can optimize anything, you have to understand where the delays are actually coming from. Because trust me, latency loves to hide in all the different layers of your application.
And there are 2 key metrics you need to know. First is time to first token, or TTFT. That's that initial agonizing wait where the user is just staring at a blinking cursor. This is all about perceived speed. Then you have time to last token, or TTLT, which is the total time for the model to finish the whole job. Both matter, but man, that initial wait is what really drives users crazy.
Now, if you're using Retrieval Augmented Generation, or RAG, well, you've just added another potential speed bump. All this work you see here, the embedding, the searching, the fetching, all of that happens before the language model even writes a single word. This can add a serious amount of delay right at the start. Okay, now for the good stuff. Let's talk about 3 super high-impact changes you can make, like today, to see a dramatic improvement in your app speed. These are your quick wins, your biggest bang for your buck. So what are the big 3? First, implement streaming. It's a game changer for perceived speed. Second, right-size your model for the task at hand. And third, add a caching layer to stop doing the same work over and over. We're going to break down each one. Seriously? Who wouldn't? The single biggest change you can make right now is to implement streaming. It doesn't actually make the model think faster, but it completely transforms how the user feels about your app. And get this, it's ridiculously simple to do. Just look at this. For the big APIs, it's often literally just one parameter in your call. Instead of making the user wait for the whole thing, tokens are sent back as they're generated, just like you see in ChatGPT. The user sees something happening immediately, which makes the app feel incredibly fast and responsive. I absolutely love this analogy because it is spot on. Not every single task needs a giant, super powerful model. Using something like GPT-4 for a simple classification task, that's total overkill, and you're paying for it with way more latency and higher costs. It's just a waste. Now, what's really interesting here is the impact of being smart about which model you use. By routing simple jobs to a smaller model and saving the heavy hitters for the really complex stuff, you can slash your average latency by 40 to 60%. That is a huge gain.
And our third quick win? Caching. Take a look at this number. You could eliminate 30 to 50% of your LLM calls. Just gone. For any app that gets repetitive questions, this is a massive saving. The bottom line is simple. Don't make the model answer the same question twice.
So you've basically got 2 flavors here. Exact match caching is the simple one. If the prompt is identical, you just send back the saved answer. But semantic caching is the really clever one. It uses embeddings to figure out if a new question means the same thing as an old one, even if it's worded differently, and sends the cached answer for that too. All right, before we go any deeper, we have to talk about the golden rule. It is so tempting to just jump in and start tweaking code. But if you don't measure first, you could be wasting all your time optimizing a part of your app that was already fast enough. So what should you be tracking? Well, you need to instrument the entire lifecycle of a request. You want to measure your time to first token, the total LLM generation time, how long your vector database query takes, your embedding generation time, and of course, the total end-to-end request time. And here's the bottom line. You can't fix what you can't measure. Measurement tells you where the real traffic jams are, and often they're not where you think they are. This lets you focus all your energy where it's going to have the biggest impact. All right, you've got your quick wins, you're measuring everything. Now it's time to level up. Let's dive into some more advanced techniques to really squeeze every last bit of speed out of your system.
Let's start with your prompts. Every single token you send to the model costs you time and money. So be ruthless. Remove repeated instructions. Use sharp, direct language. Trim your conversation history. Don't send the entire novel every time. And tell the model to be concise in its answer.
Next up, your RAG pipeline. First things first, a fast vector database is non-negotiable. Then, be strategic. Don't pull 20 document chunks when 3 to 5 will do the job. Take a hard look at your embedding models. Can you use a smaller, faster one? And crucially, pre-compute your document embeddings. Do not do that work at query time. Okay, this next one is a total mindset shift. Stop thinking sequentially. Stop doing things one after another. If you have multiple steps that don't depend on each other, run them at the same time, in parallel. You could be fetching RAG documents and making an unrelated API call simultaneously. As you can see, thinking asynchronously can dramatically slash your total wait time. So let's bring it all home with the 3 biggest takeaways. Seriously, if you do nothing else, do these 3 things. 1, implement streaming for a massive perceived speed boost. 2, use smaller, faster models for simple tasks. And 3, add caching to handle those repetitive queries. This is your fastest path to a faster app, period. And look, the best part about all of this is that you don't need to wait for some magical new, faster model to come along. The techniques and the tools to solve latency are out there for you to use right now. So really, the only question left is, what are you going to